Hi everyone, just wanted to take a minute to talk a little bit about the rhombus and the square, which are going to be the last two types of special parallelograms that we are looking at. You'll notice that I might say rhombi, or I might also say rhombuses. Both are actually deemed correct. Depends on your argument for the historical linguistics. But anyway, so what is a rhombus? Well, a rhombus is just a parallelogram with four congruent sides. So the rectangle, it's kind of like the dual one of the rectangle, right? The rectangle, we said, what if we had congruent angles? And now the rhombus, we're saying, what if we have congruent sides? So again, as it is a parallelogram, you get all the stuff from parallelograms for free. Okay? You have opposite sides are parallel. You have opposite sides are congruent. You have opposite angles congruent. You have consecutive angles are supplementary. You still have that diagonals are bisecting each other. You still have all of that stuff. Okay? That all still exists because this is still a parallelogram. But now, because it is a rhombus and we have four congruent sides, we do get a few other additional pieces of information. So if we scroll on over to our properties, we have two important ones. So the diagonals end up being perpendicular. And the reason behind that ends up coming down to the fact that if you look at these triangles, right, you can see here we have four triangles. Now, what do we know about the diagonals? Well, they bisect each other, so this side and this side are going to be congruent. We also know that because they bisect each other, this and this are going to be congruent, right? So ultimately, we know that certain angles are going to have to be congruent. And if we kind of work our way around using those sort of similar pieces of information with the various triangles, we'll find out that they all have to be congruent and therefore would all have, because all these sides are congruent, right? We're no longer restricted by that piece of information. So we'll find that all four of these are going to be congruent, which would mean that they all have to have the same angle, which ends up being 90. All right. Because again, these are a linear pair. Now, we also know that the diagonal of a rhombus bisects a pair of opposite angles, right? So the diagonal is cutting these into congruent parts, and this is a congruent part, and this is congruent to this, and this is congruent to this. Okay, so that is those are the two important pieces of information. Now, where do those come from? Again, you have congruent triangles, CPCTC, and you have congruent or bisected angles. All right. So let's do some practice with that. So we know, for instance, if DK is 8, KL is also 8. This is a rhombus, right? Everything's 8. Okay, if the measure of angle DML is 82, DML, the whole thing is 82, find DKM. Okay, well, if this is 82, this one's 82, right? This one's 82, this one's 82. And we're rhombi cut angles in half. So what's going to happen if this is 82? This part would be 41. Okay. Now, KAL is 2x minus 8. Well, what do we know about the diagonals? They are perpendicular, right? So if you have the this angle right here, that is perpendicular. So you just set that equal to 90. Uh, 2x equals 98, x will equal 49. So x is equal to 49. Now, what else do we know? dA is 4x, AL is 5x minus 3. Again, a rhombus is a parallelogram. So that means what? Well, that means that the diagonals bisect each other. So if I have dA and I have AL, I know that they are ultimately going to be congruent. So dA is equal to AL. All right, so x will equal 3. If I want dl, which is the whole thing, I would double one of these. So that would be 8x. 8x times 3 is 24. The whole thing is 24. And we can similarly do the rest of these as well. All right. But that is basically all the information that you need to worry about with a rhombus. Okay, diagonals are perpendicular and the opposite angles are bisected. Okay, so now how do I show that something is a rhombus? Well, there's a couple pieces of information that we need to worry about first. Number one, and these are true, this is true for all of these, I need to know it's a parallelogram. If I don't know it's a parallelogram, I need to start off by showing it as a parallelogram. Okay, I should not just say something is a rhombus without having first told you that it is a parallelogram. If you know that it is a parallelogram, I'm going to start with that every time, it is a parallelogram, and you have two consecutive sides that are congruent, it's a rhombus. And the reason behind that is we know opposite sides of a parallelogram are congruent. So clearly, if this side is congruent to this side, and we know this side is congruent to this side, and this side is congruent to this side, they're all congruent. So that's why if you have two consecutive sides, it works. If we can show that the diagonals are perpendicular, then the parallelogram is a rhombus. And that just comes down to the fact that if I know that this is a right angle, then this is a right angle, and this is a right angle, and this is a right angle, and I'm going to get four congruent triangles, which would, by CPCTC, give me that the sides are all the same. That's why that one works. Then if we have the diagonal, and we know that a diagonal is bisecting a pair of opposite angles, then the parallelogram is going to be a rhombus. Now, why do I know that? Well, what is this making? This is making isosceles triangles, right? So if this is congruent to this side is congruent to this side by the converse of the isosceles triangle theorem, which would ultimately then go back to our first thing, which would say the whole thing's a rhombus. So once again, you need to start off with telling me that it is a parallelogram. If you do not know that yet, then you can use one of these three. Either that consecutive sides are congruent, diagonals are perpendicular, or that the diagonal, one of the diagonals, bisects the opposite angles. All right, so let's do some practice with this. So I need to prove that this is a rhombus. I am happy to report that I am told that this is a parallelogram. So I don't have to worry about me saying it's a parallelogram. Statement. And reasons. Okay, so I know it is a parallelogram. So I'm just gonna, I do know that. I have parallelogram AECF. I also know that I have a set of triangles that are congruent, which is always helpful. That pretty much always means I'm going to use CPCTC. Remember that. Okay, and then I have a pair of sides that are congruent. All right, so if I have a pair of sides that are congruent, that usually is helpful for me somehow. Oop. Remember, if they give you something, you should use it at some point. Don't just ignore it. Please use it. All right, so we are given that piece of information. First of all, let's also make sure we're aware of which triangles we are talking about. It is these. Now, ultimately, I don't have any well, I do have this diagonal. So I only have one diagonal that is inherently drawn in, so I'm not going to worry about bothering to draw another one in. So that kind of eliminates the perpendicular idea, right? I mean, we don't really have two diagonals for me to directly work with, so why bother trying to show that two diagonals are congruent, perpendicular? I don't really have any angles yet, so let's worry about sides. I know this is congruent to this. Okay. I also know that these, the two big triangles here, are congruent. So I'm going to use some CPCTC. Okay. Now, what do I know from CPCTC? The whole thing, the big thing. Well, I know that this angle up here is congruent to this angle down here. So let me just write that. Angle ABC is congruent to angle CDA. Okay, CPCTC. Okay, we have CP. Come on. CTC. All right. Now what are we doing? Well, we have that. We have that. Well, we're almost here. Why not? Let's CPCTC it again. And let's get that this side is congruent to this side. So I know that BC is congruent to CD. Oh, my candle just burnt out. It's not. All right. So that is, again, by a CPCTC. Now, what do I have up here? I have some congruent triangles. They're just going somewhere, I swear. So I have triangle BCE is congruent to triangle BCE DCF. Okay. What's that? Side angle side. All right. Now, I have these are congruent. I can use CPCTC again. Really, it's just use CPCTC, please. So now I know that EC is congruent to CF. Well, why did I do that? Well, I didn't just do it because I was bored. I know that this is, I know that this is a parallelogram in here. And a parallelogram with consecutive sides that are congruent are they're what? They're a rhombus. So that would mean that we have achieved our goal. We just have to say that. So I have that parallelogram AECF is a rhombus. And what's our reason behind that? I've got to move my head. So what's our reasoning behind that? Well, our reasoning is just that a parallelogram with consecutive sides congruent is a rhombus. Okay, so that would be ultimately how you show something as a rhombus. As you saw there, I did use a good amount of CPCTC. It all depends on what you're given, right? I did use everything I was given. I was given sides. I used that to prove triangles were congruent. I then used that triangle to show this side, right? I used the parallelogram in saying it was a rhombus. That's the only one that we really didn't say that a whole lot in the actual proof, but you do use it to actually tell me it's a rhombus. Okay, now, last piece of information we need to talk about is a square. A square is a parallelogram that is both a rhombus and a rectangle, which means one thing and one thing alone. It has both all sides are congruent and all angles are congruent. So how do you show something as a square? You show me it's a rectangle and you show me it as a rhombus after you've told me it's a parallelogram. So squares are the most encompassing. You get you get everything else for free, right? If I tell you it is a square, that means you get all the parts of a parallelogram, you get all the parts of a rhombus, you get all the parts of a rectangle in the definition, pretty much, right? It comes with the territory, okay? So if I give you a square, you pretty much know if something's congruent, there's a good chance it's congruent, right? You know, the diagonals are congruent, they bisect each other. You know, the angles are congruent, and they are bisected. So there's a lot of information that you would know about squares right off of me just telling you it's a square. So how would I show it's a square? Well, I know it's a rhombus, which means it's definitely a parallelogram. So that means I have one more requirement. I have to show it is a rectangle. Now, who recalls how we show it is a rectangle? Well, we have two options. Right angle, which I don't directly see a way to do that, or congruent diagonals. And what do I have? ACB, which has the diagonals, hypotenuse, and DBC. Now I say hypotenuse. I technically don't know the right triangles, but they are. All right, so statements, reasons. All right, again, we use everything that we are given. We have A, B, C, D is a rhombus. That is part 1 of square, right? Now I need to show it's a rectangle. That's what that tells me. Now I have these congruent triangles. Whenever you have congruent triangles, I'm going to tell you right now, you're going to be using CPCTC. Okay? Given. Now, what do we need to do? Well, AC congruent to DB, CPCTC. CPCTC. And then finally, well, I shouldn't say that. I know it's a rectangle. I'm going to say it's a rectangle. ABCD is a rectangle. Why do I know it's a rectangle? Well, it's a parallelogram. How do I know it's a parallelogram? Because I was told it was a rhombus. So it is a parallelogram with congruent diagonals. And those are rectangles. Okay, now I have it as a rectangle and I have it as a rhombus. And I already knew it was a parallelogram because I knew it was a rhombus. So I can say that ABCD is a square. Okay, so it is a square. Now, parallelogram, both, rhombus, and rectangle. So it is both. Because I know it is both, I know it is a square. All right, now last thing I want to show you comes down to what if I just gave you those as coordinates? And then I said, how do you tell me that this is a square? Well, once again, you have to show me that something is both a rhombus and a rectangle. And then if it's both, it's a square. So when you list all that apply, it could be just a rhombus. It could be just a rectangle. And it could just be it cannot just be a square. If you have a square, you have the other two. But how do we actually show that? Well, unfortunately, the pieces of information that are most beneficial to a rhombus really come down to a couple things. Well, you would need either the distance or you would need to show me what? Well, if we scroll back up, how do we show things are rhombuses? We could show that the diagonals are perpendicular. It's not a bad idea. You don't want to do distance formula. Or you could just use distance formula. All right, so let's go through this process. I'm just going to quickly do a rough sketch here. B is -4, -5. E is 1, -5. Well, that's easy. That's nice. Actually, I don't have to worry. F is going to be -2, -1. All right, what am I? -2, -1. -7, -1. Okay, well, what can we do here? Let's look. So, first things first, I should show that this is a parallelogram. So in order for me to even say that it's a, oh, well, it tells us it's a parallelogram, I guess. So it tells us it's a parallelogram. That's great. So let's first of all figure out if it is a, let's figure out if it's a rectangle. Based on this diagram that I just quickly drew, I don't think so, but let's figure it out. So how would I figure out something's a rectangle? I need a right angle. How do I know if something's a right angle? Perpendicular. So let's look at the perpendiculars, or let's look at the sides. So let's find the slope of GB, and then let's find the slope of BE. I am going to do the slope of GF as well, just to confirm that I didn't make a mistake. All right, so GB would be Change in y is -1 plus 5. 5. -7 plus 4. What is that going to be? That is going to be 4/3. 4 over -3. Okay, that is a -3. BE is going to be change in y plus 5. Oop, oh, that's 0. Nope. Doesn't even matter what the denominator is going to be. So that would be 1 plus 4. All right, well, I pretty much know right off the bat this is not going to be perpendicular. Let's just confirm. I'm going to do GF just to make sure. Change in y, -1 plus 1 is 0. 0. Okay, so these are not going to be perpendicular because this is not perpendicular to that. So this is not a rectangle. So I can eliminate the rectangle. Also, I can eliminate the square. That being said, cannot, by this information, eliminate the rhombus. In fact, I actually know nothing about this in terms of the rhombus. I don't know anything about the sides. I don't know anything about really anything, right? So let's ask ourselves, how could I figure out if this is a rhombus? Well, I could either find using the distance formula, this distance and this distance, or this distance and this distance. It doesn't matter. I need two consecutive distances. Alternatively, I could try and look at the diagonals and see if they're perpendicular. So let's look at GE. Why not, right? Okay, GE has what? Change in y is -1 plus 5. Change in x is -7 minus 1. Appears to be 4 over -8, which is -1/2. So hopefully, if we have a slope of 2, we know these are perpendicular, so it'll be a rhombus. BF here, again, you could do distance formula. I'm not stopping you in any way, shape, or form. I just didn't feel like it. All right, so the change in y is going to be what? -1 plus 5. Oh, that's a good start. Where might it be? And then -2 plus 4. Oh, that's nice. Okay, so I have 4 over 2, which is 2. And these are perpendicular. So this is a rhombus. How wonderful. So final answer, we have a rhombus. All right. So that is just about everything that we need to cover in terms of squares, rhombus, rhombuses or rhombi, rectangles, and parallelograms. Please let me know if you have any questions and have a great day.